Okay, so now we are ready to talk about exclusive restrictions, and I think the a key thing I want to say here, just to begin with, is never do a sample selection model with appropriate selection without a exclusive restriction. Okay, then you would heavily rely on the nonlinearity of the inverse Mills ratio and functional form identification. Not good. Okay, let's just recap where we were. Okay, so you got basically your regression function of the selection sample. Well, that selected sample, that's x1 beta. I think I forgot beta one, but never mind. And then the parameter that's determining how much correlation there'll be between between the errors in the selection equation and in the structural equation times the inverse Mills ratio. Okay, now if you were to estimate this in the first step and include x1 here only and not have an exclusion restriction. So remember, x is kind of a collection of both x1 and x2. So if you had no x2, so that just said x1 here, well, then there's a good chance that these two regressors is going to be correlated, okay? Very correlated. In fact, the inverse Mills ratio for large parts of the distribution is actually fairly linear. And if you think of this being a linear function, well, then you just have essentially you essentially have x appearing twice in the same equation, and you can't really distinguish what is selection and what is the effect of x on the dependent variable. Okay, and it makes sense, right? Intuitively, it makes sense if you want to discriminate between the effect of x from selection and the effect of x on y on because of the causal effect of x, that is because of beta. Well, then you need actually to be able to explain that selection with some other variables. Okay, so you can move around, basically get variation in who is participating in the labor market. Okay, so exclusive restrictions, that is the x2. It's called exclusive restriction because we're making the restriction that it's not appearing in the structural equation. Okay, so it's assumed to affect only selection but not y1. Okay, that is crucial for identification. Okay, because you don't want to base identification on functional form assumptions like the error term being normally distributed. In principle, beta is identified in the sample selection model without exclusive restriction, but that's just due to the nonlinearity of the inverse Mills tree. We don't want to rely on that, so I would say never do estimate a Hankman sample selection model without an exclusive restriction. Actually, people are not so aware of this in the beginning. I think people are very aware of this now, and that's why you should also know. In the beginning, say, oh, well, do you have a sample selection issue? Well, I'm just going to do the Heckman two-step, right? But that's not enough. You need to do Heckman two-step with an exclusive restriction. Okay, you need to have good variation that explain why people are saying in the sample that is not explaining why they're getting higher wages. Okay, so that's clearly a limitation of this approach. It's not to diminish the contribution of this thing. It's just to highlight it can actually be hard to find these exclusive restrictions. I would say some people would say it's that's the art of econometrics, right? It's not written down in the book how you find these exclusive restrictions. Okay, so I think maybe it's instructive to talk a little bit about give some examples, and then you would have to use economic theory to motivate why a particular variable would not affect one equation, selection, the structural equation, but not this, but affects selection, but not the structural equation. Okay, that's a limitation of this particular approach, and really, I must say that I cannot really, when I was trying to write these slides, couldn't really actually find any exclusive restriction which is not subject to any relevant critique. Okay, I'm not saying that there are good people doing brilliant empirical work out there. It's just that oftentimes you end up just saying, maybe why this particular exclusive restriction may actually not be relevant. So that's it's hard to find good exclusive restriction, good instruments. Okay. So, and then it's really a non-testable assumption to test the validity of the exclusive restriction. While you can test through over-identification if you have many exclusive restrictions, but usually we only have one. So, and why don't we just so then you might ask, why don't we just test whether the instrument X2 is significant in the structural equation? Then it has this direct effect on Y if it's significant. Well, you can't do that, right? Because this is not a validation of the exclusive restrictions, because we are estimating on the selected sample. So even if X2 was insignificant, well, we can't be sure that it has no effect in the population. Maybe it has, an effect on the part that was not selected. So that's not really a valid exercise. In that sense, you have to rely on assumptions here. And that's, again, you have a problem of identification. You need to add additional assumptions. So here's some examples, and I'm going to stay just within the framework of the wage equation for women. Classical exclusive restriction is the existence of small children. The identifying assumption being that having small children has an effect on women's participation decision, but not on the wage offer. Okay, now I think that is easy to come with any critique of. And the list is long, but here's two. Small children can imply that women are restricted to working in jobs with fewer hours and lower wage. And there you got it, right? And so fewer children has basically a direct effect on lower wages. Okay, you can't be as ambitious in the labor market as you would have been if you had not had children at the time, right? Maybe you can't work that many hours after work and record videos in the middle of the night if you have to go in and feed the child, okay? Here's women's labor supply, but the same applies for men, right? It's just harder to make I guess particularly for women, it's harder to make a career and get higher wage offers if you have children. Of course, it affects the participation restriction, but also potentially the wages. Okay, and another thing is having children is really an intertemporal decision. So future birthday may depend on current wage offers. So if you see, okay, I don't get really any good job offers with good wages today, so I might as well time my children now and my fertility now and spend this opportunity for having children, while my outside option is really not that attractive in the labor market. So that's I would say that's a relevant critique of that instrument. Okay, so other people are using other instruments, and here's a and often it's often by some reform that's affecting why people they could sort into the labor market with different probabilities before and after, and or in different regions or so on. Another exclusive restriction that's also been applied, I think Marianne Simonsen used that many years ago. That was indicator for access to daycare. So in Danish it was called like pasningsgrænse. Okay, that varies across different regions of Denmark, different municipalities, and so some would have this guaranteed daycare, whereas other people living in other places would not. Okay, or it could be the degree of subsidized daycare. Okay, so the idea being, if subsidy is very high in the local municipality, where you're more likely to actually take that offer, get your child taken care of, and then you can work full time in the labor market. Okay, so that seems like a reasonable, clever exclusive restrictions, I think. And as clever as it is, it's not hard to actually come up with some critique. I'm not saying this critique is devastating, but some critique why you may actually have a violation of the exclusive restriction. So here's, for example, there's something called the T-bow model, the assorting model. Essentially, it's saying that people they choose to live where it's they sort into areas that they like. Okay, so if you really are dependent on childcare and high quality childcare to perform in the labor market, well, then you might move into a region where there's pasningsgrænse or guaranteed access to daycare, right? So the most productive women may choose to live where they can be sure to send their child to childcare, and then then you have your correlation, right? The availability of childcare is correlated with both labor supply and wages, because it's the high wage women that want to live in the areas where there's are highly subsidized kids. What I'm saying here is it's not hard to find potential critiques of essentially in any instrument that you might think of. I would say this is among the more um, better instruments, and sometimes you just have to do your best to get whatever exclusive restriction that you have available in the data that you have. Okay. So here's another classic exclusive restriction: husband's income. So again, I'm going to tear that apart. Identifying assumption is that husband's income reduces wife's labor supply, but has no effect on her wages. Okay. It's like it's reasonable. You go to job interviews, not like they ask you what your husband is earning. So in that sense, it's right? But it's still correlated potentially, right? Because what is going on the marriage market? Maybe rich people that are highly productive, they are marrying each other. And then you got positive assortative mating at the marriage market. So high productive men and high productive females, they are matching. And so then when you start to use the husband's income as an instrument that's not affecting, it's not correlated with how much you're supposed to be correlated with how much the woman is earning, well, then you are violating your exclusive restriction, because that is actually that husband's income is actually correlated with the female's productivity, and then you got a violation. So that's another example. And so here's a final example from a dynamic wage equation. We don't have to work with static wage equations. And I was trying to think of an example here with the dynamic settings, because we spent so much time with the dynamic binary response models. So here, your dynamics, your equation, you could have a dynamic sample selection equation, right? Where participation on the labor market, well, that depends on whether you're they say all the same characteristics as before, like age, experience, and so on and so forth, and maybe some testing or access to daycare or whatever instrument you have, and then also the lack dependent variable. Okay, the fact that then the idea here is that if you're participating in the labor market in the last period, that's supposed to affect the probability that you're participating in the next period. Okay, so it explains selection into the sample. Okay, and if it's true state dependence, well, that sounds like a reasonable predictor or good predictor for being in the sample in the current period if you were there in the last period. And then, so what is the identifying assumption? Well, the identifying assumption is the wage equation is static, but participation is dynamic. And so I work on dynamic models and accumulation of human capital and all these things, how you get experience, and all these are essential dynamic objects that are determining the wages. Okay, so it's not hard to find examples where this potentially is violated. So here's another a more down to earth explanation of why this might be an exclusive restriction. Don't think about human capital now. So no participation in previous period. Suppose there's no participation in the previous period because you were sick or stressed out or totally burned out. Then the fact that there's state dependence in the labor market, that makes sure the probability of participating this year smaller due to the state dependence, right? Or perhaps the worker is still sick and cannot work due to stress. Okay. So, well, the bottom line here is worker return, a stressful sick worker that's coming back to the labor market like a wounded bear is not going to take the most stressful job with high amount of workload as the first one, right? And so then you got your basically effect on a lower wage from the lack participation restriction as a causal effect, just because just because not just because of the sample selection, but because of this unobserved variable, how what is the state of that worker right now in terms of health and stress and ability to work and earn high wages. Okay, so maybe lack dependent participation may actually affect the current wage. So that's a potential issue here. I think it's a great paper, by the way, by Frank Vella and Manu Febeck. It's a great paper. So it's not to diminish it. It's just to say that many of these exclusive restrictions that people are making, well, they're always subject to some critique, and then you have to, basically think about whether these concerns are really first order, and also it can be hard to actually find really good exclusive restrictions. So that's a limitation of the approach. It's not like you can look up in Woolrich and say, where's my exclusive restriction? You have to exercise the art of finding good exclusive restrictions. Sometimes that art has already been done for you. Like you could, you could read a bunch of papers and see what other people have found as good exclusive restrictions. That's a very good starting point. Okay. Anyway, so the next topic is likelihood models, and so we're moving away from two-step procedures to like a full-blown maximum likelihood analysis, or actually partial maximum likelihood analysis, where we need to impose some more structure. So that's going to be the next video.